Good morning, everybody. All right, so the plan for today is to finish up the file system notebook, and then we're going to move on to seeing some more commands. I'm going to use a set of lecture slides. They're not on OnCue right now, but the lecture slides are basically a transcription of the command notebook. So you can read the command notebook. If you want the lecture slides, I'll put them up after class. So we were talking about the file system last class. In particular, I guess mostly we looked at the cd command, right? So changing directories, looking at the current directory as print working directory, so that's pwd, right? And you saw that with these commands, you often had to put in the name of a directory, or what's called a path. Right? So a path name, that's the name of a file that uniquely identifies the location of the file on your file system. Right? So you can have files with the same name. They can't be in the same directory. But you can have two different files with the same file name in two different directories, right? And the same is true for directory names, right? You can't have two directory names that are the same in the same directory, but you can have two directory names that are the same as long as they are in different directories. Right? And so when you specify the path name of a file or a directory is just a file, so it's the same thing. There's something called the absolute path, and there's something called the relative path. So the absolute path always starts at root. Right? So if you specify a file name starting at the root of your file system, that's an absolute path. Right? So there's a bunch of examples there, right? So just the /, that's the name of the root directory. Right? /bin, that's the name of the bin directory that's inside of root. Right? /bin/ls, that's the location of the ls command that's inside the bin directory that's inside the root directory. Right? And that thing there, which should all be on one line, right? That's the name of this current notebook on my particular file system. Sorry, actually not on this exact file system, but you get the idea, right? So absolute path starts at root. Now the absolute path can be very long, right? So if notice that the name of filesystem.ipynb, right? There's a lot of directories in front of it. So the absolute paths are often awkward to work with, right? It would be nice if you could specify the path relative to where you are now. So that's a relative path. Right? So a relative path is the name of is the path name starting at the current working directory. Right? So imagine that you're in the root directory. Right? So our working directory is root. Right? Then the name bin, that is the name of the bin directory that's inside of root. Right? bin/ls, that's the path name of the ls command that's in the bin directory that's also in the current directory, which is root. Right? So the relative path usually does not include root. Actually, it never includes root. Right? All right, so that's if you're in the root directory. What if you're in some other directory? So suppose I'm in the directory root home sys220 big sys220. Right? Then the name notes, that's the directory name of the notes directory that's inside the big sys220 directory, that's inside the little sys220 directory, that's inside home, that's inside of root. Right? And then notes/bash/filesystem.ipynb, that's the name of the file system notebook relative to big sys220. Right? So the relative path name is the path relative to the directory you're currently in. Right? And so when you use a command, you can use either the relative path name or the absolute path name if you have to specify the location of a file to that command. Right? The commands don't care what you use. Okay, so suppose you're in the root directory. Right? Then you can use a relative path to list the contents of the home directory. Right, so this wants me to enter cd/ if I'm in a different directory, and I probably am, so I'm just going to type that in here, just like that. So change to the root directory, list the contents of the home directory. Right. And you'll see that there's two users in the home directory. Right. Okay, so I'm still in the root directory. I haven't gone anywhere yet. Right. So I can use a relative path to list the contents of the directory called USR. Right? And similarly, I can use a relative path to list the contents of, is there a sys220 user? There's not. On my computer, it's Burton, so like that, right? And there's the contents of my home directory, right? On your system, you should probably, I don't remember if this works. On your system, you should change that to whatever your username is if you're following along in the notebook. Right? Again, if you type in a non-existent username here, so ABC, the command will complain. Right? So here it says that there is no directory or file home/ABC. All right, so that's the difference between an absolute path and a relative path, right? Absolute path always starts at root, relative path starts at the current directory. Okay, so I want to talk a little bit more about CD because there's a bunch of things you can do with CD that aren't obvious. So CD is the command that changes the current working directory, right? Normally, not most of the time, a lot of the time when you use CD, you'll pass in a path name to change to some specified directory. If you type in CD on its own, right, then it switches to your home directory, right? So that switches to root home Burton on my computer. Right? All right, so there's the symbol tilde, which you might have trouble reading. You should be able to read that. Tilde is this thing here. So it's that. Normally, on a standard North American English keyboard, it's in the upper left-hand side. It's the upper leftmost key. But if you have some international keyboard, I don't know where they are. Right. Tilde expands to your home directory. Tilde is special. Right? So you're going to see this in a few lectures. There's a bunch of special characters in Bash. One of them is the tilde character. Tilde here is actually what's called a path name expansion. Sorry, it's called a tilde expansion. Right? Tilde expands to the name of the current user's home directory, but it is possible to change that. Right? So CD tilde also changes to my home directory. Right? If you were a different user, so suppose you were the user Homer Simpson, then CD tilde would change into root home/Homer Simpson. Right? So you saw dot in the last class, right? So dot is the name of the current working directory. So notice that dot is also special, right? It has a special meaning to the shell, right? So if I switch to the home directory with the first CD, right, print the current working directory and then CD dot, that's not going to do anything. Dot is just the name of the current directory, so it's not going to go anywhere, right? So it goes nowhere. And finally, dot dot, that is the symbol representing the parent directory of the current directory. Right? So again, switch to the home directory, print out the name of the home directory, right? And then go up to the parent of the home directory, and then print the name of that directory. Right? And so here, my home directory is root home Burton, right? If I switch up one directory, that just goes to root home. And you can chain these things together, right? So I can do cd dot dot slash dot dot, that goes up 2 directories, right? So that goes to the grandparent of the current directory. Right? So home directory, my home directory is home Burton, 2 directories up is root, right? So I'm now in the root directory. Okay, there's another special symbol, so there's a minus sign, right? The hyphen. So the hyphen here is a special argument to CD, right? Is it special on its own? The hyphen is used to indicate options to commands. Right? So when you, the CD command interprets the hyphen on its own as saying you want to go back to the directory you were last in. Okay, so here I'm going to switch to the root user directory. I'm going to switch to my home directory. Right? Now remember, the directory I was last in was root user. So if I do cd minus, that goes back to the directory I was just in. I was previously in, sorry. Right? So go to the root user, so there I am. Then switch to my home directory, right? And then cd minus, that goes back to the directory I was previously in, right? So that goes back to root user. Okay, and finally, what did this do? Oh, right. Notice that it does something unusual compared to the other versions of CD, right? So if you just type CD on its own, insert below, right? So if I type CD on its own, it prints nothing, right? It switches to the home directory and prints nothing. If I specify some path, home, why don't we go to user bin, right? It prints nothing, but you are actually in root user bin, right? So cd on its own normally prints nothing, right? With the hyphen, so cd minus, that is the exception, right? So when you type cd minus and run that, right, it prints where it ends up, right? And that's because it's off, well, one of the reasons why is because it's, when you switch back to the directory you were previously in, you might want to check to make sure you're actually in the directory you think you were in, right? So by default, it also prints out the name that you currently end up in, right? So that's a bit weird that the way that works, because no other version of CD, no other option to CD, or most of the other options to CD do not print out the name of the directory that you end up in, right? If you want to suppress that output, you can use cd tilde minus, right? And so now, if you look very carefully at the output, right, it doesn't print out the name of the destination directory. But if you print it out manually, you'll see that you are, in fact, in root user, right? Don't bother memorizing this. I'm never going to ask you about this, right? This is very strange the way this behaves. Okay, so there's the end of the file system notebook, right? So we now know how to you basically know how to navigate your file system now, right? Or you know the basics of navigating the file system. So assignment 1, which will come out probably tomorrow, but it might come out later today. Assignment 1 is going to make sure that you've got a Linux system working, or that you have access to some Linux system somewhere, right? And that you can navigate a file system and work with some commands, right? So you'll be able to do the first, I don't know, quarter or half of the assignment 1 after this lecture. So that assignment will come out later, today or tomorrow. All right, so let's jump to the next topic, which is looking at commands in more detail. Right, if you came in late, the slides aren't up on the lecture slide right now, but they are basically the same as what's inside the command notebook. Right, so I'll put the slides up later, later today. All right, so commands in Bash. There's actually 4 different types of commands, or broad categories of commands. Right? So you can have what's called a built-in command, right? And that's just a command that your shell happens to understand, right? So our shell is Bash, right? On your Mac, it's Z shell, right? That program actually understands a certain number of commands natively, right? So those are all built into the shell program itself. Right? So things like cd and pwd, these happen to be shell built-in commands. Most commands that you use on your system are actually not built-ins, right? So they're not native to the shell directly. There's some other program that's written in some other language, right? It doesn't matter what language it's written in, right? It can be any language as long as it produces a runnable program. Right? Most of the Linux commands that you would use, most of the standard Linux commands that you would use, are all written in C. Right? But they can be some other programming language. Right? So a lot of them are also scripted languages, right? Like the Bash language itself. Right? They could be written in Python. They could be written in Perl. They can't be written in Java, because to run a Java program, you actually need a Java virtual machine. So they can be written in Java, but to actually run it as a command, you need a separate shell script to drive that command. Oh, sorry. There's something called an alias, which we don't really talk about. Well, I don't talk about it in this course. Right? So an alias is something that the programmer can make up, which is basically an abbreviation for some other command. I'll show you an example of that shortly. We're not actually going to make any aliases in this course, right? But it's useful to know that they exist. And finally, you can write a function in your shell scripting language, and that can also serve as a command, which is a bit unusual, right? So in Python, if you were to write a function, you wouldn't expect to be able to run that function directly from the command line. That's not the case in Bash. So in Bash, you can actually write a function you can write a function, put it in a file somewhere, and you can actually treat that as though it was a separate command, which is a bit odd. All right, so there's 4 different types of commands. So occasionally, or very occasionally, it's useful to know exactly what kind of command is that. Right? So the command type, if you pass it in a command, will tell you what type that command actually is, right? So is it a built-in command? Is it a regular command? Is it an alias? Or is it a function? Right, so let's just run that in the shell directly. Right? So type cd. Right, so I'm going to ask what kind of command is cd? Well, it's a shell built-in command, right? So it's a command that the shell natively knows. Right, what is ls? So ls, we've actually seen ls before, right? If you remember from the previous lecture, we know that ls is this program that lives somewhere in root, where is it? Root bin, right? So there's actually, if you go and look in root bin, ls root bin ls, right? You see that command is actually, there's actually a file called ls inside the bin directory, right? So ls is actually a program that's is actually a separate file which corresponds to a program in the bin directory. Right? So you might think that if you did type ls, it's going to print out that it's a regular command. Right? But in this case, it actually prints out something unusual. Right? It says ls is actually aliased to ls minus color equals auto. Right? And so this minus minus color equals auto, that's an option that passed into the ls command itself. Right? And that just says if the terminal supports it, print out information in some sort of color encoding. Right? Exactly what that color encoding is different for every shell, right? And you can change how it behaves as well. Right? But it turns out that on my system anyway, ls is an alias. Right? So when you type in ls, what you actually get is ls space minus minus color equals auto. And then there's one more. What's the other one? LA. Oh, and LA is another alias. Right? So LA is short for ls minus capital A. Right? Oops, sorry. If you wonder what minus capital A means, right? So when I type in ls in my home directory, it just prints out a bunch of stuff. Right? If I type in ls minus big A, it prints out the same stuff, but it prints out some extra stuff. Right? It also prints out stuff that starts with a period. Right? So remember, any file or directory whose name starts with a period is considered to be a hidden file in bash. Right? And so you can see in my home directory, there's a whole bunch of hidden files. Right? There's a bash history, there's a bash logout, there's a bash RC, right? And so on and so on and so forth. Right? Typically, hidden files are used, well, in your home directory, they're often the name of directories that contain configuration information for other commands, or information that other programs need to see. Right? The user is typically not concerned with what's in these files or in these directories. Right? But programs like bash, right? So bash actually reads your bash history, your bash RC file, and things like that. Right? Those files or directories contain information that are relevant to other programs. Right? So anything that starts with a period, hidden file. Minus big A will list all files, including the hidden file. Notice what's not listed, though, right? Dot and dot dot are not listed. Right? So the current directory and the parent directory, the shortcuts to those aren't listed. If you really want to list those as well, that's what little a is for. Right? Little a is the same as big A, but it also shows dot and dot dot. Right? Okay, so it's often convenient to see the hidden files in your directory, right? Which is why, on my computer anyway, the command LA exists. Right? It's a shortcut for a commonly used option that you would pass into the ls command. Right? And so that's the same thing as typing in ls minus a. Now this might not be the case on your systems. Right? So especially, I don't know how it behaves at all on Mac, whether or not LA is automatically aliased to ls minus capital A. Right? A lot of Linux systems will create the alias for you. But I don't know if that's true on Mac. Okay, if you want to know where a command actually lives in your file system, that's what which is for. Right? So which, if you pass it in the name of a regular command, will tell you where on your file system is that command. Right? So if you type in which cd, it prints nothing. Why does it print nothing? Because cd is a built-in command, right? So it's not actually on the file system, right? It's a command that the shell natively understands. Which ls says that ls is actually, the ls program is in the directory or has the full path name root user bin ls. Right? So if you happen to need to know where does a command live on your file system, you can try which. Okay, so ls on its own, so ls is one of the most commonly used commands when you're navigating, because it's when you're navigating through a file system and all you can see, all you have is a terminal. You often need to know what exactly is in this directory, right? And so you need to know information about the directory or a file, and that's what ls is for, right? So ls lists information about files. On its own, it just lists what files are in the current directory. But if you pass it in a path name, it lists whatever, it lists the information for what that path name corresponds, for whatever that path name is. Right? So if what am I supposed to type in here? Sorry. cd bin and then lsls. Okay. So I'm going to go to the bin directory, and then I'm going to type in lsls. Right? And it says, there's the file ls, right? Why is there the file ls? Because if I actually list the contents of that directory, there's actually a file named ls here, right? So ls, if you pass it in a name of a regular file, right, it just tells you, assuming that the regular file is actually there, it just prints out the name of the regular file. If it's the name of a directory, it prints out the contents of the directory. Okay, so like most other bash commands, the ls command has a whole bunch of options that you can pass to it. Right? So if you want to know how big is a file, that's what the -s option is for. ls -s ls. Right? So that says that the file ls is 140 units big. Right? Now, you might wonder what the units are. And so the units are in something weird called the block size. So that's not important. It's just not in kilobytes or bytes or something that's human readable. Right? If you want something that's human readable, you can ask for ls to print out the information in human readable form. So that's what the h is for. Right? So ls -s and h prints out the size of the file in a human readable format. ls -shls, right? And now you can see it's 140 kilobytes, right? That's what the K means here, right? So what I just did there actually uses two options to ls, right? It prints out the size, and it prints out the size in human readable format. When you specify the options, you can specify them separately, right? So you can write ls -s space -h. And then ls, and you get the same thing. Right? So options can often be combined into one single option, like that, or you can write them separately, like that. All right, so in general, commands in Linux have the following structure. Right? So it's the name of the command, followed by a hyphen, some set of options, possibly none. Right? If there are no options, then there's no hyphen either. Right? And then you pass in some information to the command. Right? In the case of ls, you pass in one or more file names. Right? So your options, these are optional flags that modify the behavior of the command. Right? The arguments, space-separated list of items on which the command acts. You can usually combine options. So ls minus big A S H1, right, asks ls to list the contents of the current directory, right, printing out the hidden files, but not dot or dot dot, printing out the size of each file in human readable format in one column. So each file is printed on a separate line. So ls minus, minus big ASH1, like that. Right? So it prints out every file, one per line. The file size is printed out in human readable format. I don't know if there's any hidden directories. There's too much output here. This is not a great example. If there were hidden files, it would also print out the hidden files as well. Let's do my home directory and see what happens there. Okay, so let me do it this way. Control L. There. Okay, so I'm now in my home directory, right? And you can see that the -A option also prints out all the names of all the hidden files as well. All right. I'm not going to type this in, but this corresponds to what I just wrote in, with minus big A SH1. Right? So when you're typing stuff in directly from the command line, you typically use what are called the short form options. Right? So typically these are a single character long. Right? Each option corresponds to a single character. Right? The problem with the single characters is unless you use them all the time, often, it's often hard to read what are these options actually doing. Right? So I've used Linux enough to know that -A SH1 does almost all files, print out the size in human readable format in one column, right? A lot of commands, not all, a lot of commands will also accept what are called the long form options, right? Easier to read, right? So here, when you read this, it's like, oh yeah, you're going to list all the contents of the directory, almost all the contents in human readable format, including their size in one column, right? That one is easy to read and understand what that's going to do. I'm not going to type that in because it's going to take me too long and I'm never going to type it in correctly anyway, right? So typically you wouldn't write that from the command line, right? Where you might use this form is when you create what's called a script, so a bash program, right? Where you've actually got a file that contains that line of code. Right? You're going to see that the bash programming language is just a sequence of bash commands, right? With some other stuff as well. Right? So if this was inside of a file somewhere that you wanted to run as a bash command, right, you might choose to write it this way so that someone who comes along and reads your script later on can actually understand what the script is doing without having to look up all the options. Right? But from the command line, you're typically using the short form options. Okay, so ls has a lot of options. This is only some of them. Right? So minus big A, we saw that it's almost everything, and it shows all the hidden files except for dot and dot dot. Right? If you really want dot and dot dot for some reason, use little a, but you almost never need to print out dot and dot dot. Right? Minus D is interesting. So if you're inside of a directory, so if you specify a directory name, this is a bit complicated to explain. So if you specify a directory name to ls, then typically ls will list the contents of that directory name. If you pass in the -D option, then ls won't list the contents of the directory name. It will only print out the name of the directory instead of its contents. Now that doesn't sound useful right now, but you'll see on the assignment that there is a case where there are many cases where it turns out to be useful. Right? -F prints out some additional information to indicate what the file type is. Right? -L is another commonly used one. So -L prints out what's called the long format information. Let me just quickly see if I have it. I just want to quickly scroll through. Okay, so let's look at -L very quickly. Okay, so ls on its own just lists the names of the files, right? Files and directories. -L, so that's an L, not a 1. Right? So with the -L option, you get what's called the long format information. Right? So this lists the quote-unquote detailed information about the files, right? So your file name appears in the last column, right? And then a bunch of other stuff also appears, right? Don't worry what the other stuff means right now. Later on in a few lectures, we'll explain exactly what all of these pieces of information are. When you use -L, you don't always get the same information depending on which version of, well, depending on your operating system. So there is no standard output format for the -L option, right? Typically, you get the file name in the last column, and you often get information that looks like this, but you don't always get information that looks exactly like this, right? So there's no standard for how this is printed out. That is on my particular computer, I think that is the modification date. So that is the date at which the file was last changed. That's the file size in blocks, not human readable format. That's who owns the file. That's something called the group that owns the file. Again, don't worry about that for now. This stuff we'll see later on is important, right? Those are what are called the permissions on the file. Again, not important for now, right? Okay, so you've got all these options. Is there any way to figure out what these options mean? The answer is yes, right? Many commands will accept --help as one of their arguments, right? And that will list the documentation for that command. Not all of them will, right? So not all commands have --help, right? Some of them do. Many of them do, sorry. Right? So that's certainly one way to do it. For you, the easiest way to do it is to just look it up on the internet, probably, right? Because for new users, it's very hard to read this documentation. And you'll see why in just a second. So ls --help. Right? So good luck reading this, right? Unless you're extremely patient, right? This is not the easiest documentation to read, right? It's not a tutorial, right? There are no examples, right? It's simply information documenting what the options are for the command, right? If you are trying to solve some problem and you don't know what option you need to use, right, this is often not very useful, right? But that's one way to get information about the command. If you happen to know that one of the commands is a shell built-in command, right, you can use the help command, right? So help space built-in command name will give you the help for the built-in command. So help cd, right, prints out some documentation for the cd command, right? Again, remember cd is a built-in command. I don't know what help ls prints. Let's see, help ls. Okay, so if you type in help ls, right, that doesn't work. Why? Because ls is not a built-in command. Okay, if you have an executable command like ls, right, then that typically, but not always, has what's called a man page, right? So it's, we saw this briefly in the previous lecture, right? So man is another command, right? So man is the manual command on Unix, right? So the manual command will read what's called the man page information for a command if it exists, right? If it doesn't exist, it'll complain, right? And it will print out help information about the command. Now, the problem with man is it's a whole separate program. So now you need to know how to use the man program. So let's take a look at what it does first. So man ls. Okay, so notice here that you get one screen of information. You don't get all of the information at once, right? So you get one page of information, and now you have to navigate the man page, right? So what you're actually in is you're in another program now, right? You're in a program that displays the contents of the man page, right? And so I can go forward in the man page by pressing the space, so that goes forward one screen. I can go back by pressing the B, that goes back one screen. Right? When you look at the contents of the man page, right, like a lot of other computer documentation, there's no standard for the information in a man page, right? So not every man page looks the same, unfortunately. Right? So you can write it's possible to create a man page that looks very different than this, for example. Right? But typically what you'll see you'll see something under the name section, or hopefully you'll see a name section that tells you the name of the command. You'll see the synopsis, which is the very brief information about how to use the command. Right? In the synopsis part, anything that's inside of square brackets is typically optional. Right? Dot, dot, dot means there can be more than one. Right? So that square bracket option dot, dot, dot means 0 or more options. Right? Here you've got file in square brackets. So file is the name of a file. Right? So it's the path name of a file. Dot, dot, dot says there can be more than one. So that's interesting. We haven't seen that yet, right? So you can pass more than one path name to ls, right? And ls will list the contents of each one of those things sequentially, right? We'll see an example of that shortly. Right? Then you'll come to the description section, and so look how big this man page is. So these are all the options, right? So there's a lot of them. So lots of options. Each option is briefly described, and then there's often more information after the options. Right? That looks long, but that's not anywhere near the longest man page that you'll run across. Right? Similarly, this looks like a lot of options. Right? But again, there are commands for commonly used programs that have literally thousands of options. So the compiler that you're going to use in the C course, in the C part of this course, is one of those programs, right? There's an enormous document that exists that explains what each one of the options are for the compiler that you use to compile C programs. All right. Now, are you supposed to remember all these options? The answer is no, right? For the most part in this course, right, there's almost no required memorization of what the options are, right? So in other words, when you go to sit down to a quiz or an exam, right, you don't have to remember what the vast majority of options are, right? You might have to know the common ones. So minus big A for ls, for example, is useful to remember, right? But typically, I'm not going to ask you a question that requires you to have known some obscure option on some command somewhere, right? So don't be concerned about memorizing the options. If you end up using Linux a lot, it'll become natural to remember the options, right? But for the most part, most people just look them up, right? And so don't feel bad about having to look them up, right? That's exactly what you should be doing. Right, now navigating these man pages, if you want to learn how to navigate it, there's a little bit of information here, right? There's lots of ways, there are a lot of equivalent ways of navigating the man page, right? But again, for the most part, I think for most of you, the easiest way to find information about a command is just to look it up on the internet. Okay, so here's an example of using man, right? So that's the CISC program again, right? And this is another good example, right? Notice that the CISC program, the man page, does not look the same as the man page for ls, right? There's not really any, right? So remember, the ls listed all the descriptions for the options here in some nice, easy-to-read format. CISC is pretty terrible in its man page. If you want to find out what the options do, you actually have to read all of the sentences. They're not listed out one at a time for you. Right? Oops, sorry, wrong one. Where'd we go? Oh, no. Okay, so when you're working on the command line, you'll realize that there's a lot of times you want to know, look, I just typed in this long command and it gave me some useful information, and I did that like a few minutes ago, right? I may have forgotten exactly how I did this. So is there a way to go back and look at what commands did I type in? The answer is yes, right? So there's a command called history that lets you look at the history of commands that you've typed into your terminal. Shell? I can't remember if it's a shell or terminal, right? Let's take a look at that. So if I type in the command history, right, it spits out a long list, so a very long list, right, of all the commands that it has remembered that I've typed into the terminal, right? So you can see that the last command I typed in was the history command, right? The command before that was man cow say, the command before that was man ls, and so on and so on and so forth, right? The number here is useful, right? So the number here is just an integer value. It's not necessarily, you don't know necessarily where the number starts at, right? So what the origin is. But if you typed in a command, right, and you want to redo that command, right, and you happen to have its history number, then you can redo the command using its history number, right? So suppose I wanted to redo the LA command that's back here, right? So that's command number 2078. I can type in exclamation mark 2078, and that redoes the LA command for you. Right? And so if there's some command that you need to remember that you did a while ago, right, then it might be useful to look at the output of history and see if you can't find that command again. Right? So that's often useful. Oh, sorry. Bash has a feature called tab completion. Right? I mentioned this briefly in the last lecture. Right? If you start to type in a command, right, if you type in the first few characters of the command and press tab, Bash will try to auto-complete the name of that command. Right? So for example, if I type in the word cow and then press tab, so C-O-W and tab, oh, so mine doesn't do anything. Right? If I press it again, right, it will then list out all of the commands that your shell happens, that my shell happens to know about. Right? So if I type in cow, tab, tab, right, it lists all the commands that start with the sequence cow, right? If I type in cow, then S, and then tab, there's only one program that starts with cows, so it auto-completes the rest of the command, right? It also works with file names, right? So if you type in a command name, and that command name needs a file name as one of its arguments, your shell can also auto-complete the file name, right? So apparently, cowsay lives in root user root / games. Oops, sorry. So if I type in ls root user games, and then cow, and then an S, and then press tab, it auto-completes the name of the file. Right, and now you can list information about the cowsay program there. Right, so auto-completion is handy to remember it exists. Right, it saves you from having to type in a lot of stuff. Right. Do I need to talk about this? I don't need to talk about this right now. Okay, I want to jump to the command notebook very quickly because there's something that's not in the. Okay, so in the command notebook, we're all the way down to almost the very end. Right. So we just talked about command completion. What's not in the slides is this part here. Right. And so in Bash, you can enter what's called a list of commands. Right. So a list of commands is just a sequence of one or more commands. Right. You separate the commands with one of these four things here. Right. Okay. Now don't get confused here because these look a lot like some of the symbols you've used in your programming language you've taken before. Right? They don't mean the same thing here. Right? Okay, so the semicolon, that's your command separator. Right? So if you type in a list of commands, you can separate the commands with semicolons. Right? So cd tilde, switch to the home directory. Semicolon, so that ends that command. Print pwd, print the contents of the directory. Semicolon, right? So that ends the command. ls, right? So this actually executes three commands. Right? cd, print working directory, and then ls. Right? You can type it all in on one line if you like. You don't have to, but if you want to, you can. Right? And it does the exact same thing as if you had typed in the commands all one at a time. Right? Okay, so when you type in a sequence of commands separated by a semicolon, it runs the commands sequentially. Right? So this command runs first. The shell waits for that command to finish. That command runs second. Shell waits for that command to finish. That command runs third. All right, so what does and bar do? Well, let's take a look. Okay, so the single ampersand after a command runs the command in what's called the background. Right? Now, for our purposes, this isn't super useful because a lot of you, if you're using the the Windows subsystem for Linux, you don't really have a graphical user environment, right? All you've got is this terminal. If you run a command that happens to lives a long time, right? So for example, if you try to start up Eclipse from the command line and it happens to be installed on your Linux system, right? If you just type in Eclipse, it'll start up the Eclipse program. Eclipse shows up, and then your terminal will no longer accept new commands, right? So the way, when you launch a command in Bash, typically what happens is Bash, the terminal, or the shell, I guess, will wait for the command to finish before it gives you back control of the shell. Right? If you type in the ampersand after the command name, what happens is the shell launches the program in a separate subshell. So it actually creates a new process, runs the command in that process, and then gives you back control of the shell immediately. Right? So that's useful to know if you're working, if you're doing stuff like starting up a program like Eclipse or some other long-lived program from the command line. Right? You're not going to typically have to do that in this course. Okay, so what about and? Or ampersand. All right, so command 1, ampersand. Command 2 runs command 1. Whoa, sorry. Oh, this is what you see if you actually double-click on a cell that doesn't contain code. If you do that accidentally, just run the shell, run the cell. So cell, run, and there you go. Okay, so the command 1, ampersand, command 2. It runs command 2 only if command 1 ran without any errors. Right? So cd tilde and or ampersand ls runs that command. If that command succeeds without any errors, it runs the second command. Right? So this should always work. Right? cd tilde always should take you to the home directory. ls lists the contents of that directory. So not surprisingly, that lists the contents of my home directory. Okay, if this command fails for some reason, the second command will not run. Right? So cd some made-up directory name, ampersand ls, will stop after trying to switch to the non-existent directory name. Right? So notice what the shell prints out. Right? It says when you try to use the command cd with the argument dir name, right, there's no file or directory called dir name. So that command failed with an error. Right? Because that command failed with an error, the second command does not run. Right? Okay, so what about the double bar? Command 1, double bar command 2, runs command 2 if and only if command 1 actually failed. Right? So if this first command fails, command 2 will run. If the first command succeeds, command 2 does not run. Right? So you can combine all of this stuff together. Right? Which is why if you go back to here, right, you'll see that there's a note on the precedence of the operators here, of these separators here. All right, so what does this do? Okay, this tries to switch to some non-existent directory, right, that we expect should fail. If this command fails, run this sequence of commands. Right? So here I'm going to make that directory called dir name. I'm going to switch to that directory and then print the contents of, print the name of that directory. Right? So this only works, right, if this fails. So let's see what happens. Right? So you get the error message from the first cd. Right? So that command failed. However, everything else now runs. right? And you now see that you are actually in the directory root home Burton dir name. Now, why is this important, right? So why would you ever want to do this, right? So what happens if this command doesn't fail? Right? If this command succeeds, I don't want to make a new directory called dir name, right? So if that command, oh yeah, I'm in the wrong directory. Sorry. So, sorry, hang on. I just need to cell insert cell below. Okay, so I need to cd back to my home directory. Okay, now I can go back to here, right? Now, that command succeeds. And away you go, right? Okay, so that's it for today. I will see you tomorrow.